You know, every single day you click on links, you send messages, you watch videos, and it all just happens. It feels instant, almost like magic. But behind that one simple click is this incredible super high-speed journey through a wild world of wires and waves and rules. So today, we're going to follow that click from the very start all the way to the finish.
Seriously, have you ever stopped to think about it? That click isn't just a command, it's the beginning of a conversation, one that zips across the entire globe in just milliseconds. So let's pull back the curtain and see what's really going on.
All right, so here's our game plan. First, we're going to meet the two main characters in this digital story. Then, we'll get into the secret rulebook they have to play by. After that, we'll actually trace the physical highway our data travels on, see how it finds its way with a digital address, and learn the language it speaks. And then, we'll wrap it all up with the final digital handshake that makes the whole thing work. Let's dive in. At its heart, the internet is built on a really simple idea. One computer asks for something, and another one provides it. That's it. This one relationship is the foundation for pretty much everything you do online.
Think of it this way. Your web browser, that's the client. When you click on a link, your browser is the one making a request. That request travels out to a really powerful computer called a server, which is holding the web page you want to see. The server's job is to provide that service by sending the page right back to you. It's this simple dance, this back and forth between a requester and a provider that's happening billions of times a second all over the world.
Now, you might have heard about another way of doing things called peer-to-peer. That's where every computer can be both the client and the server. But just imagine for a second trying to go to a website like YouTube if it had to rely on millions of different individual computers to send you videos. It would be total chaos, right? That's why for the massive scale of the web, the client-server model is absolutely essential. We have these dedicated, powerful servers that are built to handle millions of requests at once, making sure you get what you asked for and you get it fast.
Okay, so before our click can even start its trip, it has to get packaged and prepped according to a very strict set of rules. You can't just send a raw click out into the void. Nothing would understand it.
These rules are called protocols. And what's so interesting here is that it's not just one rule. A protocol is a whole system of etiquette for computers. It makes sure that a message sent from, say, an Apple laptop can be perfectly understood by a Linux server. It manages everything: timing, size, the actual format of the message. It's the universal translator.
And any communication, and I mean any, boils down to these three things. You've got a source, which is your computer, a destination, the web server, and a channel, which is the physical path in between. So by following all these rules, our simple little click is now a perfectly formatted message, all packed up and ready for its journey.
So let's talk about that channel, the actual highway that our data is about to travel on. It's so easy to think of the internet as this invisible cloud. But trust me, it is a very real, very physical thing.
The very first leg of your data's journey is almost always going to be one of these two. If your computer is plugged in, that request zips down a physical cable. If you're on Wi-Fi, it starts out as radio waves. But here's the thing. Even those wireless signals eventually have to hit a wired network to go the distance.
And let's just geek out for a second and look inside one of these cables. Right at the center, you have a copper wire carrying the signal. It's wrapped up in all these layers of insulation and shielding. And that's not just to make it tough. That shielding is absolutely crucial. It protects the signal from all the noise out there. You know, interference from power lines or other electronics. Without it, the data for your click could get scrambled and the whole request would fail before it even left your house.
Okay, so our data is perfectly packaged, it's on the physical highway, but the internet is a massive maze of billions of devices. How in the world does our little data packet know where to go? Well, it needs an address and a map.
The most common way devices talk is through something called unicast. Just think of it like a private one-to-one conversation. Your computer, the source, sends its request to one and only one specific destination, the web server. It's exactly like sending a letter to a specific mailing address.
But sometimes, a device needs to talk to everyone nearby. That's a broadcast. This is like your device standing in the middle of a room and just shouting an announcement to everybody there. It's not for one person in particular, it's for anyone who's listening. This happens a lot when a device first joins a network and is trying to figure out what's around.
And then we have multicast, which is this really clever middle ground. It's a one-to-many message. So instead of shouting to everyone or whispering to just one person, it's like sending a message only to a specific group of people who said, "Hey, I'm interested." This is incredibly efficient for stuff like live video streams. The server sends out just one stream of data, and only the devices that are actually watching pick it up. It saves a ton of bandwidth.
So where does your device get its address in the first place? It happens through a process called DHCP, and you can think of it like this quick 4-step conversation. First, your computer broadcasts a discover message, basically yelling, "Hey, is there a DHCP server out there?" A server hears it and replies with an offer, saying, "Yeah, you can have this IP address." Your computer then sends a request saying, "Awesome, I'll take it," and the server makes it official with an ACK, or an acknowledgement. And just like that, you've got a temporary address to use on the network.
So our device has an address, it knows the server's address, but hang on a second. We don't type in long strings of numbers when we go to a website, do we? We type in names like theexplainer.com. So there has to be one more translation step.
And this is the job of the domain name system, or DNS. It's literally the phone book of the internet. When you type in a domain name, your computer asks a DNS server for help. The system works its way from the end, from the .com or .edu, all the way down to the specific name to find the matching IP address. It's only then that your request can actually be sent to the right machine. Now, once your browser finds the right server, they need a common language to actually make the request. For the web, that language is HTTP. Think of it like ordering at a restaurant. Your browser is the customer, and it uses an HTTP GET request to say, "Hi, I'd like the main page, please." The server, which is like the kitchen, then uses HTTP to respond, "You got it," and sends over all the pieces of the page, the text, the images, everything.
We've covered the rules, the roads, the addresses, the languages, but there is one final fundamental piece that makes this whole client-server chat possible at the software level. How do the two programs actually plug into each other?
The answer is something called a socket. Now, a socket isn't a physical thing you can hold. It's a software endpoint, kind of like a numbered doorway on a computer. A web server opens up a socket and just listens for requests on a specific port. For web traffic, that's usually port 80. Your browser then connects its own socket to the server socket, and boom, that creates the final direct communication link, the private channel where the whole HTTP conversation can finally happen.
So, from a simple click to a client-server request, governed by protocols, flying across physical networks, navigated by IP addresses, translated by DNS, speaking a language called HTTP, and all connected through these software doorways called sockets. It's this invisible, unbelievably elegant dance of technology. So the next time you click a link, maybe you'll just pause for a split second and appreciate the amazing journey you just kicked off.